Thank you, Dr. Sanjay Vakchure Sahab. Sunil Gupta ji, thank you very much. So, I welcome all the participants for the first session of the today's program. So, basically, I will be covering on the different waste material. Fly ash is basically in detail, and I will be covering different other waste materials also. And also, I think you must be knowing that recently one code of practice has been already IRC has just printed IRC SP 132. So most of the studies are from CRRI. We have done so many studies on different waste materials. Based on that, only the maximum the code of guidelines have been now printed, approved by the council. So I will be dealing with that now. So I will just share my slides now.
Sir, only request is that if you just restrict your presentation with the fly ash, that will be far better because this will avoid the repetition and it will be easy for other faculties to deal with their respective subjects. Thank you.
No, no, Dr. Sanjay, actually there will not be any repetition. I have seen the there will not be anything. I will be telling extra what is covered in our IRC SP 132 because I think the in detail, as you said, it will be fly ash will be covered in detail. Other waste material also, which is not available in the country, and the people should know it. So the participant, and there will not be any repetition in the other courses.
Welcome, sir. Thank you very much.
Okay, thank you very much. So, are you able to see the slide?
Yes, sir.
Hello?
Yes,
Sir,
sir.
it is visible, sir. You
It's
are
visible.
audible
Oh,
and visible, sir. Please continue.
visible. Okay. Okay, just to have the introduction, Dr. Sanjay already has given you the introduction little bit about why we are looking into the waste material for road construction. So India has a wide network of roads, 56 lakh kilometer, includes NSDP, National Highway Development Program, and then you know that PMGSY programs, then Mukhyamantri Gram Sadak Yojana programs are there. Then the special accelerated development for Northeast is there, that is called SARDP. So we have totally 56 lakhs being built all over the India, out of which expressways are 1500, national highways are 1 lakh, and around rural roads are the maximum around 40 lakhs. So see, so much road has been built, and we required huge amount of aggregate materials and soil also for the road construction. Like if you know that recent days, in most of the cases, the quarries have been banned. The banning of the quarry is there. So there are a lot of, because of the environmental concerns. So it has been banned. So if you think about the quantity of the materials, like about 20,000 ton of good quality aggregates or soil per kilometer is required. So you know that 56 lakhs of kilometers, so they are the large network. You know, you can visualize how much huge quantity of materials are required, either soil or the aggregates, for embankment purposes, or for your granular layers, or for the bituminous mixes. So it's a huge requirement, and we know that it is not available within the economical lead in some of the states like Northeast, and as Dr. Sanjay told about Bihar, West Bengal. So they are not available in the within the economical lead. So when it is not available within the economical lead, what happens is there will be a lot of delays. So naturally, large distances they have to cover for bringing the material. Then the delay will be there, and also when there is the distance is more, lead is more, the cost is also tremendously increases of the project. So apart from cost, so delay is also a cost. So you mean to say it's a huge burden on the exchequer if you think of the good quality aggregates. So, for example, in the state of Tripura, aggregates are brought from Assam. So they have to go around and bring Assam, or they have to be imported from Bangladesh. You know that I think some of the people know Agartala is just a border. So it has to come through the Bangladesh. So in the state of Tripura, in the Mizoram, they are available also very at large distances. Very local materials are there. Other parts like do problems exist in Bihar, West Bengal, Rajasthan, Madhya Pradesh. So a lot of problems are there. All over India, there is a problem of these aggregates and soil material. And you know that mining is also it results in the reduction of the green belt. So green belt, and there is a removal of the fertile soil, and the depletion of water table also takes place. See, because of the road construction, see, road construction requires huge amount of water also. So there will be a depletion of water table. And suppose if you take for embankment construction from the agriculture land, you are removing, or nearby you are removing a most fertile soil, and that is also affecting our environmentally. And mining, I think the green belt is gets reduced. You know, the so much problem is there of the pollution these days. And fertile soil, you know that even a 1 meter of fertile soil takes thousands of years to form. Thousands of years to form 1 meter fertile soil. Suppose if you are go on taking this fertile soil for your road construction, for embankment or subways or any other purposes for the road, then all fertile soil, there will not be much land left for the agriculture, and we will not be leaving anything for our future generation. So because of this, so we should avoid this fertile soil to be taken up. Instead of that, you have to go for some waste materials and other locally available which is not useful for agriculture. They have to use it so that the environment is protected. Environment is protected. So the alternative is utilization of waste, locally available waste material. So that provides the environmentally preferable alternative. So which are dumped haphazardly on a costly land with limited usage. So these waste materials they are dumped also. Even industry is facing that problem. Industry has got they are all the recycled materials. As Dr. Sanjay told, it is not a waste. I don't want to call it as a waste. It is a resource material. It is a recycled material, and we should be able to use those material instead of soil or aggregates, so that our depletion of natural resources can be cut, and then the environment is protected. So that is most important. Mm. So some of the potential waste material in the country, if you say, we have coal ashes, so basically fly ash, bottom ash and pond ash, they are the coal ashes. Copper slag is there, the waste from copper industries. Iron and steel slag is there. Zinc industry, we have from the zinc slag and Zerofix. So depending on the processing from the zinc ore, we have two materials of waste from zinc waste, zinc slag and Zerofix. Phosphogypsum, it is from the fertilizer industries. Chrome industries, we have chrome slag. Kimberlite tailings, it is from the you have the tailings are there, that is from the gold mines. And foundry sand from the casting industry, there's huge amount of foundry sand is being used. C&D waste, you know, from construction industries. Municipal solid waste, basically from the landfill, whatever you see, the huge landfills in different parts of the country. So that is also we should be able to use it. Tire waste are there, glass waste are there, rice husk ash. So these are all the different waste material we can think of utilizing it in the road construction. So what is the R&D status in India? Actually, the problem here in India about this waste is lack of awareness and database. So people are not aware of it, what type of waste materials available in the country, and where it is available, what is its location, and what is its characteristics, whether it can be used or not. So the lack of awareness is there already. And in the country, lot of, including CRRI, number of laboratory studies have been carried out, but very few data is available on the actual field applications and long-term performance behavior. So actually, whenever before we use it, apart from the laboratory characterization, though you will find out that the material is very good based on different laboratory characterization, its performance should be evaluated in the field. In the field, how it is performs in the field, and what is its behavior under the traffic movement. All those things are necessary so that the people have the confidence that this should be used in the road construction. And what is happening is, for the implementing authorities like you are from NHIDCL or from NHAI or from your PWD, there is a lack of time is also there. So you cannot experiment. So the nodus lies with CRRI to investigate or other research laboratories, and they have to come with the code of guidelines so that you implementing authorities can use it without with confidence level. That is the most important. And also there are a lot of doubts are there in the mind of the implementing authority, how the roads will perform with these materials, with this material. So this uncertainty is because of the lack of confidence, non-availability of codes and specifications. So we know that as a research institute, CRRA has done a lot of research work. So then recently discussed this at the IRC, and we have brought out a codal guideline, IRC SP 132 2020. In this year only the council has approved, and it has been printed, and you can refer that, which covers different waste materials for the utilization in the purposes. So we have covered our 5 major chapters like fly ash, copper slag, zero fix, marble dust. So phosphogypsum, where CRRA did laboratory characterization, as well as we laid it in the field, we constructed some test action, we undertaken the performance evaluation, we did it. Then when we are sure, we have put it in the guidelines. So it is almost 5 chapters are there that can be easily, the material can be taken and directly use it. And we have covered other waste materials also, like chrome slag and other foundry sand and municipal solvent. They are all potential waste material. Only on those materials we have done only the laboratory characterization. So field studies are yet to be done. Anyway, we have given go ahead for the implementing authorities to use those materials in their field, and you yourself can make some experimental test sections if you feel you are good. So you can carry on with the further construction. So we have given in the guidelines go ahead for those materials which are only laboratory, because see, only CRRA cannot do all the research for all the materials. So even the implementing authorities can themselves take some stretch, and then when they feel it is good, go ahead with the other stretch construction. So in that way we have given in the guidelines. So that's how so whatever the ways I am covering is based on the recent guidelines what we have printed by IRC, that is SP 132. So I will be covering in detail about the fly ash. Fly ash is basically from the power stations, 200 million tons per annum it is produced, and percentage utilization is only 50 to 60% in the concrete bricks road embankment, agriculture. So these are the major thing where the fly ash is used. So you know that apart from the NTPC power stations, we have other industries which have their own captive power plants. So there are huge number of power stations in the country which produces huge amount of the fly ash that should be used. Otherwise, it is occupying, as you see in the figure, it will be occupying costly land like this, and you see the dust in the figure. How the dust when it dries, see fly ash also it dries very rapidly. So when it dries rapidly, the air pollution will come into picture. Surrounding towns or villages will get affected. So all these problems are there, and we should be able to use this material so that apart from our cost gets reduced, and we are also protecting our environment. So we should be use fly ash in the road construction. So if you think of what is fly ash, see fly ash, what we term is a generic term. If you technically, fly ash, we call it as a generic term, but it includes all the coal ashes. Actually, it is a coal ash. Coal, when you burn the coal at 1300 to 1400 degrees centigrade, so some of the ash which flies off the chimney through the, when you burn it, it flies off the chimney, and that is called fly ash. That flies. See, it is the term itself gives you the meaning. Fly ash means that flies the chimney. Bottom ash is some of the when you burn the coal, some are sintering will be there, and it will collect at the bottom of the furnace. That is called as the bottom ash. Pond ash is, see what is pond ash is actually in the country, for your information, there is a dry disposal of the ash from the power plants, and also there is a wet disposal. Pond ash is from the waste disposal system. What they do in the power stations, fly ash that flies off the chimney, they will mix it with water, and bottom ash also they mix it in the water, and don't, the both together they pump it to a pond. Means slurry of the fly ash plus slurry of the bottom ash, it will be pumped into a pond, and that is called as the pond ash. Pond ash, we call it as a pond ash. But nowadays the all industries are preferring fly ash because fly ash can be used in the concrete also. So once if you mix with water, its reactivity will get reduced. So but still now we have huge amount of pond ash because until now we have a wet disposal systems only. If you go to Dadri, Dadri is a dry disposal. So the fly ash is very active, and there is no pond ash in Dadri. And fly ash is also exported to Nepal and other places because fly ash can be used as a replacement of cement also in the concrete. So that is a dry disposable. We call it as a fly ash. Mound ash is basically it is put in a mound. Like in Dadri, we have a big mound like fly ash and some bottom ash. They dumped on a surface of the land. So it is not a, it is a dry disposable only. So that is called as a mound ash. So in generic, whenever we call in the say fly ash means it may be fly ash, it may be bottom ash, or it may be pond ash. So that's how the terminology has been used. So as I told you, there are 2 million tons, 200 million tons is produced per annum in India. It will reach out to 600 millions by 2032. They are expecting 600 millions. It's a huge amount because see our country is depending on the coal only. Coal as a for our energy needs. Though we are now going for renewable energies like solar and gas and other things, we are going in that direction now. Recently hydrogen bus, but still coal is the primary source of energy for us. So we can, so slowly we have to transfer it to the renewable other sources. So fly ash production will go on increasing because ash content in the coal, whatever we have in the source, is 40 to 50% is the ash content. So there will be a huge amount of ash that will be accumulated in the, by 2032 it is expected to be 600 million tons. So it is expected. So out of this, I told you only 50 to 60 is utilized in India. 40% is still dumped either in the pond ash or in the mound. So without any usage, this 40% is a huge amount. So that we are creating a lot of health hazards, pollution. So in the nearby town and nearby cities, so we should go for 100% utilization. And even if you find in other countries, they are almost 100% utilization in the developed countries. So in our country still we have to move fast for the use of this. Whenever you find that fly ash is available in the country near the site of construction, whether it is a rural road, whether it is a major district road, urban road, or any other state highway, you should yourself you should be go with the fly ash usage rather than bringing a soil for the road embankment and road embankment construction. So then only when you as a implementing authorities take the lead, then only we can go for the more utilization, and also we are protecting the environment, society as a whole. And but in the urban and industrial areas, fly ash provides a alternative to natural borrow source, which are scarce, expensive, and inaccessible. Say in a urban area, suppose you go for Delhi or any other Bangalore or any of the major cities. See, we actually we don't have the soil at last, because all is a developed area. We have power stations. So in that cases, if you want to have a development in the cities, urban areas, you are forced to use fly ash. Like in Delhi, we have a Rajghat or Dhadri nearby, and Badarpur stations are there. So even now, the PWD, CPWD who are doing a lot of construction, they are not getting fly ash also, because it's all even flyovers, fly ash is used. All road construction, it has been used. Now you know that any city number of flyovers been built in urban area is very huge. So in the approaches, fly ash is used. So even fly ash is also not available. Fly ash is also not available in the urban areas, because we are forced to use it. So that doesn't mean that only when we are forced to use it, you use fly ash. No, you as a implementing authority, even the fly ash is available. If the soil is available just nearby, don't use the soil, go for fly ash. So indirectly you are helping the society as a whole, and also it will give you economy in the road construction also. So that should be the uh, important. So if you think about the mm problems of the environmental issues, it's a air pollution is already there. From I told you in the figure also, there is a air pollution, because there is a dust emission from the ash pond. And fly ash, if you dump it, whether it is a dry or wet disposal, water pollution may be there. See, the dust and all, it accumulates, and some of the heavy metals, if at all, if it is possible, gets contaminated in the ground and the surface water also. So pollution of water is always there. And if you are dumping in the industrial area or nearby industry, so it is a very costly land. You are unnecessarily using any costly land which otherwise could have been used for development of the area. You are using it for the dumping. So you are that is also not correct. It is very waste of that land. It's a huge lands are being used for waste dumping. You can use it for good development of the society. Land degradation is also there. If you are not using, because you are not able to, the costly land, you cannot use it for agriculture. You are dumping your fly ash or any other waste material. So these are all the environmental issues you should think of. It is whatever I am saying, it's for fly ash, but it is true for other waste materials also, like the zinc slag, Zorofix, copper slag, all are same problems of this pollution and dumping, loss of land. So these are all there for all the materials. So what I mean to say is you have to use the effective utilization of fly ash at the source or from the ponds that to protect the environment, and you have to protect the environment, and it also reduces the cost of the project also. So the cost of the project also is reduced, and also the your environmental concerns, you are protecting the society also. That is very important. See, fly ash usage, we call it as a any waste materials, we call it as a sustainability. Sustainability in the road construction. Sustainability is what exactly? You must be reading in the all newspaper about the carbon footprint reduction and other things, and we have to go for sustainability in the every aspects of our life. So in the road construction, sustainability is basically social. It includes three components: social, society you are protecting, environmental you are protecting, and the economy. Economy is the money you are also saving. So society, the cost, and the environment together we call it as a sustainable. So whenever you use any fly ash or any other waste material, we are protecting the society from the pollution. So there is a societal benefit here, and environmental, anyway you are protecting the environment is because of the air pollution, as I told you, because of the land saving and the underground water saving. So indirectly it is helping the society also. The health of the people are protected. So society and environment are interdependent. So in that way, use of the waste material are contributing. And economy, so naturally when you have a aggregate or soil which has to be carried out, which has to be brought from large distances, so naturally the lead will increase. When the lead increases, the cost increases. So the total cost of the project that increases. So suppose if you have a power station nearby, maybe around 10 to 15 kilometers, and you can achieve the economy by using the fly ash instead of the soil. So in that way, the cost of the project will be reduced. I think you must be knowing there are gadget guidelines are there for fly ash. So they have to provide a free of cost within the lead of 100 kilometer or something. So that is also economizes the lead. So the implementing authorities need not provide the cost for transportation of the fly ash. The production people, the industry people will provide you free of cost at the site for the construction. So utilization of fly ash in the road construction is so basically fly ash, it may be a pond ash, it may be bottom ash. It is used for the construction of the road embankments. Road embankment. You know that road embankments, it may be the height may vary depending on the terrain of the area. Suppose if you go to some of the hilly areas or nearby hilly areas where the depth of embankment will be very huge, maybe 3 meter, 4 meter. Yeah, or in a plain area like Delhi also, if there is a low-lying area where I want to carry on the road construction, then there will be height of the embankment maybe 4 to 5 meter. So the huge amount of material is required for the road embankment, and I think instead of soil, if you are able to use fly ash, so it is a very good alternative that will give the protection of environment and cost reduction also. So road embankment only we can use the bulk utilization in the construction. And other usage are as a backfill, retained fill and reinforced fill. Suppose if you go to urban areas, you know, urbanization is going on in all the states, all the cities, where number of flyovers construction has increased tremendously in the each city. So where you will bring the material? There is no material available, but maybe some power stations are there. So approaches is also, it consumes lot of material in the flyover approaches, like it is around 200 to 300 meter approach, and the four laning means four laning, it's a few more than 15-20 meter width, 20 to 25 meter width, and then you have a very huge amount and either approaches of the flyover. You have a big quantity can be used. It is so in such places also we can use in the reinforced portion also we can use it, and also we can use in the retained portion, and the retained and in the center portion also we can use it. I will show you some of these slides there. We can just think about that, and that is flyovers, that is there. Rainflows fly ash as a basal mattress. So the basal mattress is basically the reinforced fly ash is basically we use a geosynthetic material with bottom ash for the in the case of some waterlogged areas. In the waterlogged areas, you want to construct a road. Suppose you want to construct an embankment of 4 meter, 3 meter, 4 meter embankment. If you want to construct on a waterlogged area, so naturally the bottom portion of the embankment on which you are going to construct an embankment is really very weak and slushy, and if you go it, the whole embankment will settle down. So in such cases we can go use fly ash along with some reinforcement like geotextile or geosynthetic material at the bottom, and you can use as a basal mattress. So we have done some project earlier. I will show that slide so that you will understand what is that basal mattress and what is that reinforced fly ash. And pavement layers also you can use stabilized fly ash. See, I think you must be knowing that IRC 37 2018 now the ministry is propagating use of stabilized material in the subbase and base. See, subbase and base, you want huge amount of aggregate. Suppose if you are able to replace with stabilized material there, lot of saving in the aggregates are there. So they are propagating go for stabilized material, replace the aggregate granular layers with the stabilized materials, so that you will save the aggregates and then the environment and the society as a whole. So in such layers also you can go for, instead of stabilized soil, instead of local soil, I don't want to use soil, you can go for stabilized fly ash. Stabilized fly ash in the subbase base, replace the your subbase base, and then that will give a huge impact on the saving of the aggregates and the environment. And in concrete, lime fly ash, DL dry lean fly ash, concrete, roller compact. So these are all concrete area. Tomorrow you have a lecture. Mr. Satyendra will be covering all those in the concrete portion. He will be covering there. I will be restricting my lecture to basically embankment and the subgrade, basically embankment, so that you can wherever how to go about the use of the fly ash in the embankment portion. So replacement of cement in concrete in the wearing course, that also you will be covered by tomorrow's lecture by Mr. Satyendra. So other applications, not only in the road portion, flyovers and concrete and other things, you can go for manufacture of cement also. So in the manufacture of cement as a replacement of silica, siliceous material, you can use cement, and you can use fly ash for the manufacture of cement. Dike construction. What is this dike construction? So in the thermal power station only, we have a few pond is there. Pond, it should be raised. Actually, there also dike is also an pond ash can be capacity can be increased. So in the dike also you require huge amount of soil. We can use whatever the ash is there only, you can use it, and properly if you design it, you can use fly ash. I think in our all power stations people are using fly ash for the dike construction also. Floor and wall tiles, you can go for wall tiles also, floor tiles also. Refractory bricks also now they are going in a huge way. Ceramics, recovery of metal, extraction of cenospheres. Have you heard of cenosphere? I think if you go to a pond, if you go, you are happen to visit a pond area in the power station, very light particles, very shining particles will be floating on the water, and very light particles so that floats on the water, that is called cenosphere. Materials, you can use it for very light materials for the manufacture of the aircraft body parts, because very lightweight. So cenospheres has got huge demand. So you can get this cenosphere from the pond area, you can recover those cenospheres and you can have a make money out of it, cenospheres. And in the open cast mines, underground mines, you know that mining is a huge job. Ores you have to remove, whether it is a zinc ore or it is a copper ore, or sometimes coal also you have to mine it. Coal also you have to mine it. So there will be lot of open cast mines and there will be underground mines. So after you extract the ore and use it and get the metal, what you will do with the pits that is formed? So you have to use some material to fill it up, like you can use fly ash if it is available, and you can fill it up with the fly ash. Absolutely, there is no from us. And the manufacture of fertilizers and in agriculture. Oh, fly ash is used. I think you must be knowing it. They are using in fertilizer manufacture and agriculture. Agriculture basically, fly ash is a porous particles. It's got some porous particle, so it absorbs water and keep the moisture for long time. So once if you put fly ash in the agriculture purposes, the moisture is maintained so that the seeds will germinate, and also your whatever plants, so they can have the continuous source of water. So it has got a very good purpose, and it has been proven that it can be used for the agriculture purposes also in the fly ash. I want to go about some of the statutory guidelines that is there from the Ministry of Environment, Forest and Climate Change. So they have issued various notification for fly ash utilization. Principal notification was issued on 1999 and was subsequently amended, while notification dated 2003, 9 and 16. So they will go on amendment this one. In that, it is very clearly stated that use of fly ash in the construction of road and flyover should be within a radius of 300 km of a thermal power plant. So it's very mandatory you have to use the fly ash in the construction within the radius of 300 km of a power plant. So you should be able to do it. And fly ash shall be used as per IRC SP 58. It is now 2001. Now we have included fly ash in the recent guideline also, SP 132 also. You can take up the details in the characteristics from that SP 132 also. And apart from the mandatory use of fly ash within 300 kilometers, soil required for top side cover of the embankment of roads shall be excavated from the same site. Suppose you are constructing a fly ash embankment. Actually, normally I didn't go for show you the design details. Normally, fly ash will be covered with a soil because of its erosion problem. So for the earth cover, you need not bring the soil from the other side. In the same place where you are constructing a fly ash embankment, you excavate the same portion and then keep the soil ready and then use it for earth cover. In that way, what you are doing is you are saving the land. You are saving the land of the agriculture, saving the soil. See, earth cover is a must. It's a 0.3 meter, 0.5 meter width or 1 meter width, whatever quantity you require. From the base only you excavate it and then use it, so that you are saving the costly land. You can save it for agriculture purposes. No person shall be within the manufacture clay bricks, tiles, bricks without mixing at least fly ash with soil. So at least 25%. Suppose somebody is manufacturing bricks and other things, at least they use the 25% fly ash with soil. They have to go for the bricks also. So not only for road construction, they have to go for if somebody is preparing for tiles or wall tiles, floor tiles or bricks or refractory bricks, they have to mix 35% fly ash. Otherwise they are going against the rules of the land. So you have to go, otherwise the action may be taken according to the bylaws of the provided. Another is, no agency, person or organization shall within a radius of 300 kilometers by road of a coal or a lignite based thermal power plant undertake or approve or allow reclamation and compaction of low-lying areas with soil. Again, see, you want to carry a road over a low-lying area. Low-lying area, you want to construct a road. You cannot fill up the low-lying area with a soil or a local soil. You have to use a fly ash. You have to bring from the power station, fill up the low-lying areas, and then go for road or another reclamation or whatever you want to do the land for utility. So you are compulsory, you have to go for the fly ash, and only fly ash shall be used for compaction and reclamation. Second is stowing of other statutory guidelines is stowing of mines and backfilling of open cast mines in 50 kilometer to be undertaken with a mix of, again here also there is a guideline. I told you earlier, I indicated the open cast mines filling also, whether it is a underground mines or open cast. If it is within 50 kilometer from the mine area, you have to, if the power stations is there, at least 25% fly ash you have to use it. Along with that, whatever other tailings that is removed during the mining operation, you can mix it, no problem. But 25% is the quantity that you have to use it as per the guidelines for its utilization. Another notification from the Ministry of Road Transport, S&R, via their circular number 240. This is a circular issued in 2018. That is the circular issued by the 2018. So as per the para 10, what the circular issued by the ministry, the cost of transportation of ash for road construction projects, NH or SH, or for manufacturing of ash-based products, or use as soil conditioner in agriculture activity within a radius of 100 kilometers from a coal or lignite based thermal power plant shall be borne by the such coal or lignite based thermal power plant, and the cost of transportation beyond the radius of 100 kilometers and up to 300 kilometers shall be shared equally between the user and the coal and the lignite based thermal power plant. See, this is a para 10 given by the ministry guideline. So what shall I explain this? Basically, if you are constructing, we have a highway projects or PMJSY projects or any other road projects or any other, you are manufacturing the bricks from the fly ash within a, or in agriculture within a radius of 100 kilometer from the power plant, it is as per the statutory guidelines, the generator of the waste should supply to the implementing authority free of cost at the site. So within the rate, he has to incur the transportation cost. But beyond 100 kilometer and within 300 kilometers, suppose, in that case, if it is more than that, then it has to be shared equally. It has to be shared equally by the generating industry and by the generating industry and the implementing authorities. So if it is beyond the this one, so that's what I think you understood about the para 10. Para 14 is the coal or the lignite based thermal power plant shall within a radius of 300 kilometers bear the entire cost of transportation of ash to the site of the road construction. So shall within a radius of bear the entire cost of transportation of projection under Pradhan Mantri Gram Sadak Yojana, other asset creation programs of the Government of India, buildings, road, dams and embankments. So the coal and lignite based shall within a radius of 300 kilometers of the Government of India. So this you have to find out. So whether you have to bear the cost for between 100 to 300, share the cost, or for the PMJSY it is clear, for the low cost roads it is be 300. That you have to find out how much is the sharing you have to do it. So that's about the statutory guidelines. So this is the like a fly ash, how it is looking. It is a shape of the particle. It is scanning electron microscope. Just I want to show you how the fly ash particle looks. It's all porous particles. You see here, it's a porous lightweight particle. So it absorbs lot of water. That's why it is used as a conditioner in agriculture also. For you can, and also it absorbs more water. The OMC itself in a road construction, OMC itself it will be more on 25%, 30% OMC. So naturally it absorbs more water because of the porosity of the particle. About the other characteristics like the specific gravity, if you look at the specific gravity, it is 2.19. 2.19 is very light. So because of the porous particles, specific gravity is very low and density is also low. That is the interdependency of specific gravity and the density. So very low density as compared to soil. Soil is around 2, you know that it is 2.6 or 2.68. Loss of ignition is also 1.4%. So 1.4 is means carbon content is also very less in the case of this. Specific surface area 4000 centimeters square per gram. If you see the chemical characteristics, silica is 61%, alumina 30%, iron oxide 4%. All other materials like lime, CaO, magnesia, sodium, sulfates, they are all less only. So major component of the component of this is silica, alumina and the iron oxide. If you together, if you see 95% constitutes the total. Out of 95%, major is silica. So it is a siliceous material. See, that's why it is used in the manufacture of cement also, or this one. So when silica, alumina and all are there, that shows that it is a pozzolanic material. Pozzolanic material. What is pozzolanic material? If you add cement or lime, it reacts with siliceous and aluminous material and makes aluminum silicates or aluminum silica, aluminum so the calcium aluminate. So these are all the bonding gels. So it reacts. So the binding action will be better if you have a silica alumina. It becomes a pozzolanic material. That's why I am saying stabilized fly ash. When you mix with cement, stabilized fly ash, so that can be used as a sub base and base also instead of your aggregates, because clearly the chemical characteristics indicates is a pozzolanic material. So that we will have a good reaction with the cement or lime. Regarding the geotechnical properties of the fly ash, geotechnical property of the fly ash, specific gravity, you just compare it. You just compare the pond ash and soil. Specific gravity of pond ash is between 1.9 to 2.55. Soil you see here 2.65 to 2.68. So that shows that it's a light material because of the as I told you in the scanning electron microscope, very porous particles, so very light compared to soil. See, light, it's a lightweight is always sometimes advantageous. Where it is advantageous, like suppose you want to construct a road on a very soft soil or a very low bearing capacity soils. Suppose if you use a soil, the bearing capacity is low, there will be settlement in the embankment, soil embankment. Suppose you use a fly ash, it's a lightweight, you are putting a less thrust on the ground. So naturally lightweight hasn't got an advantage when you use in the road construction. Plasticity, it's a non-plastic. For non-plastic is always good for our road construction. Silty, sand type of soil, sands are all good for road construction. We want non-plastic materials. Non-plastic materials will have less settlement. Will have less settlement and very nice. So, but in the case of soil, it all depends. Plasticity depends on the type of soil. Suppose if you have a clay soil, very high plasticity. Gravel is also sometimes plastic, something. So silt also sometimes it may be plastic also. So as compared to soil, it's a non-plastic. So non-plastics are better than the plastic soils in consideration of the settlement of the embankment or subgrade. So indirectly it will use stability of the road construction. So maximum dry density and OMC. So dry density is 9 to 16 kilonewton, means it varies from 0.9 to approximately 0.9 to 1.6 gram per cc. In the soil it is 1.2 to 2 up to 2 gram per cc. So it's a heavy weight. See, I told you specific gravity and MDD are interdependent. When specific gravity is low, the dry density is also low. When specific gravity is more, the density is more. So dry density is less. So density is less means, but in the that is good for the lightweight material, good for the low bearing capacity soils wherever there. Optimum moisture content you see 18 to 38%. If you take average, so it is around 25% is the optimum moisture content. In soil it is 15%. So high moisture content it absorbs because of its porosity. It absorbs moisture. So that's why the ash optimum moisture is more. Cohesion is negligible in the pond ash, but cohesion is there in the case of the soil. Angle of internal friction is 30 to 40 degree. See the phi angle when you do by direct shear or shear test, it is 30 to 40 degree. If you compare with the soil, it is 20 to 45. So it is the angle of friction is much more in the case of fly ash as compared to the soil. See the phi and C, the cohesion is a very important geotechnical parameter when you use fly ash for the high embankments. Whenever you use got 3 or 4 meter, 5 meter fly ash embankment, the slope stability depends on the shear strength of the soil. Shear strength of the soil depends upon the shear strength characteristics. That is basically the C and the phi. That is the C and the phi. They are the much more. In the case of the that is the point of this one angle of quant of consolidation. These are all consolidation characteristics. The next parameters are all CV and CC. What is consolidation? Shear strength is basically C and phi, that you use it for the stability of the slopes. So stability of the slope is very important, whether it is a soil embankment or it is a fly ash embankment. If phi angle is more, C also contributes in the shear strength, so your slope will be stable. Otherwise, if it is a low phi value, then you have to go for flatter slopes for the stability. So you have to estimate the factor of safety. You have to go for the slope stability analysis. So 30 to 40 degree indicates that even you can go for steeper embankments, fly ash embankments, it will be stable. Considering the consolidation characteristics, if you find here pond ash, it's the consolidation characteristics is also good. That means that it's the consolidates very fast in the field. So once it consolidates more, means it gets settlement will be over within the construction period. There will not be any post construction settlement. That's what compression index is also says that 0.05 to 0.2. This is very low compressible. You don't expect any settlement after the construction. Very minimal settlements. That's what we want. We want that the settlement should be over within the construction period, so that there will not be post construction settlements. When there are no post construction settlements, then your bituminous road, there will not be any rutting. It will be in the roughness will be in a proper condition. But as you compare the quant of consolidation compression with the soil, I feel that fly ash is better than the soil in terms of its consolidation characteristics. Permeability is also good. So 10 raised to minus 6 to minus 4. So permeability is also better, means there will not be any permeability water. It is better, means there will not be any development of pore water pressure. So it is good for the construction of the embankment. If you see the grain size distribution, basically it is a silt size. You see 80 to 85%. It varies. So it is a silt size material. It varies like 7 to 90 depending on the type of fly ash. If you go for pond ash, there pond ash you have more bottom ash, sand content may be more. If you go for pure fly ash, silt and clay content will be more. Basically silt will be more, and clay content will be around 10% only, not more than 10% will be the clay content, clay size particles, but the silt particles will be more in the fly ash. So pond maybe the silt content can reduce, sand content may improve, because there is a mix of bottom ash also, that is coarser materials. So like that will be there. So this is how the comparison of the fly ash and the soil. If you study this, already I have discussed with this, you can conclude that fly ash is a non-plastic in nature, which results in high permeability. It is a very non-plastic. So what happens is high permeability of the fill. So I want the permeability of the fill is required, because there is no development of the pore water pressure. Higher shear strength leads to greater stability. I told you already, we have 30 to 40 degrees the phi angle, and C is negligible, and so it gives greater stability, greater factor of safety for the slopes with the fly ash. Low value of compression index, CC is compression index, means only 0.05 to 0.1. Very low indicate that they are very less compressible. Less compressible means less settlement in the field. High value of the rate of consolidation indicates faster rate of settlement. See, the rate of consolidation is high, so rate of settlement is also more, so settlement will be finished during the construction. There will not be any post construction settlement, so that also indicate that it is very good. I don't want any post construction takes place, so that my surface cores like my bituminous granular layers get settled, and then I get a rutting at the surface, so roughness, I don't want that. So in that way, fly ash we use in embankment is better than soil. I don't expect, so the settlement will be over within the construction period. You don't find any post construction settlement, so that your surface will be very smooth, rough for the riders. Can be compacted under inclement weather conditions. What it means? See, fly ash is a non-plastic material. Suppose if a rainfall comes, what happens? See, it becomes, the fly ash will absorb water, but the optimum moisture content, I told you, itself is around 30%. Suppose if even if the water rainfall happens, and you can see that water content increases, it can be compacted easily, even in the rainfall conditions also. You cannot do with the soil becomes because it becomes a plastic. But here this material is like it is a non-plastic material, and it also absorb water, so it can be easily compacted. That is under the inclement conditions. That is not possible with the soil. And 15 to 20% saving in construction cost, depending on the lead distance. So there is a saving in the construction. I have already told you there is a construction. In general, what I can say about fly ash, seeing its characteristics, physical characteristics, chemical characteristics, what I can say, fly ash is a silt material, but behavior is like a sand. You talk like that. Fly ash is a silt material, behavior is sand. See, when you think fly ash is a sand, you can usually use in the embankment purposes. It will be very good material because there is a non-plastic material, high shear strength, settlement is less, consolidation is faster, no post-construction settlement, slope stability is very good. So you can say that fly ash is a silt, behavior is the sand. So it is a wonderful material for the road embankment construction. So typical cross-section design details, if I just give you as per IRC SP 132, it's a roadway width and with the shoulders. So we have indicated this is for a highway, national highway. This is how we have to construct. Fly ash can be in the core of the embankment, and cover soil is in the sides of the, like you can see here, there is a cover soil in the side, and fly ash here and the fly ash here. So if the height of the embankment is 1 meter, more than 1 meter, cover thickness may be 1 to 2 meter as per the site conditions. So you can go for, normally in a highway, it will be more than 1 meter. So you can go for a cover thickness of 1 to 2 meter in the measured horizontally for the soil with the proper soil. You cannot use any clay soil. It should be as per the specified soil that is used for embankment as per your ministry specifications, like minimum density criteria, PI should be low, FSI should be less than 50%. So whatever the soil you are using for embankment, the same soil should be used for the cover soil purposes also. thickness of the cover soil may be 1 to 2 meter. You can decide as per the size. It may be 1 meter also, it may be 2 meter. The engineer in charge can decide based on the site conditions. And we have provided, we have given intermediate layer in the fly ash core of 0.2 meter every 2 meter height of the embankment. What is this intermediate coil layer? Means after you construct a 2 meter fly ash, you provide a 0.2 meter of the soil layer, and then again construct for 2 meter of the fly ash, and again 0.2 meter. So go on doing that. It depends on the height of your embankment. Every 2 meter you provide a 0.2 meter. What is this? Why cover the intermediate layer of soil? Intermediate layer should be provided. See, as far as stability, as far as the slope stability, it doesn't affect. You can go on with fly ash without any intermediate cover also. It doesn't affect you at all. You go on doing it, your stability will not be affected. But why it is recommended is, suppose if 2 meter you are constructed in the field and afterwards a rainfall comes, immediately fly ash will be flown. Whatever efforts you are done for 2 meter thickness, for maybe for you are done for 1 kilometer, everything will get washed away. Everything will get washed away. So better to confine it. You go for the cover soil every 2 meters, so that whatever work you are done is safe. It is basically from the practical purposes point of view, in the rainfall conditions and all, 0.2 meter is recommended. Otherwise, if it is a dry area, you can go as it is. You can go on doing with the fly ash without any problem. But with the cover soil, with the sites, you have to compact fly ash, cover soil together. You have to cover soil together, and then only you have to go on constructing. You cannot construct the fly ash separately and cover soil separately. You have to go on constructing together. That is how the recommendation is given, and go up to the top of the embankment. So what is happening is, fly ash, there is a confinement has been given for the fly ash, and along with the cover soil in either sides. So you can raise that, you can slowly raise it to the top of the subgrade, and whatever subgrade recommendation is there, or good soil, whatever as per the DPR, you can use it. Then the other granular layers, sub-base, base and other bituminous can be used. So this is how the section in the case of a national highway. And in the case of rural roads, basically rural roads, there is no intermediate cover, because basically it is less than 1 meter only, less than 2 meter only. 90% of the cases it is less than 2 meter only. So there is no intermediate cover. Directly you lay fly ash along with the cover thickness. So cover thickness may be 0.3 meter, 0.3 to 0.5 meter is sufficient if it is less than 1 meter. If you are, because normally in PMGSY road, only the filling is 0.6 meter, 0.8 meter. You go for 0.3 meter cover thickness, that is more than sufficient. No need to go for more soil, the soil cover thickness, because unless again you are using more amount of soil, then where is the sustainability? Go for lesser thickness cover soil. That is sufficient for the low heights embankments. Only 0.3 meter, 0.5 meter can be constructed. So then you go for the rise it like that, then the subgrade and the other bituminous layers or whatever is there, you can go about it. Granular layers and the layers. So detailed construction methodology, you can refer that. But basically you can how to go about the construction is, first is clearing and grubbing, that you are doing with soil embankment also. So the ground shall be stripped to a depth of 150 mm. The ground shall be stripped to a depth of 150 mm. You have to strip it. So whatever you strip it may be used as a cover soil. So that's what I told you. Whenever an embankment is there, embankment you want to construct on a land, you have to strip the soil, and whatever the soil is there in that portion only you can use as a cover soil. You need not bring the cover soil exclusively for the fly ash. Unnecessarily you are wasting a costly agriculture land. So better to use the stripped soil only, but after cleaning that stripped soil 150 mm, whatever organic matter is there you remove it and other things, and then that type of soil you can use it as a cover soil. And the stripped ground shall be compacted to achieve 95% of the in the 95% of degree of compaction in the national highways, 98% in the case of the rural road. 95% of MDD, basically the degree of compaction should be 95% of the maximum dry density of the material uh, before you lay the first layer. So I think most of the people, I don't know, PWD people, what they do is, okay, they are stripping even for soil embankment or other thing. They strip the soil, but they never find the density of the stripped ground. That is a must as per the Ministry of Road Transport or MORD guidelines. You have to check the density, right, and the degree of compaction of the ground that you have prepared for the embankment. Only when you achieve 95% for national highway, 98% for the rural road, then only you go for the first layer of soil or the first layer of fly ash. So it is also the same. We are also, suppose you, before you use a first layer of fly ash, collect the soil of the base, do the MDD, and after stripping, collect the soil, do MDD of the ground. After that, go with a core cutter or sand replacement and get the field rate density. That degree of compaction, whatever you should be 95%. Otherwise, again compact the ground before achieving 95%. Then go for the first layer of the fly ash. That's what it says. The side cover of the required width shall be provided along with the core and mechanically compacted as the embankment progresses upwards. The specification of the side cover, I told you, is same as the embankment. Whatever embankment specification are there in the MORD or in the Ministry of Road Transport Highways, specifications are same. What are those specifications? Specifications is basically the dry density specification. It should be more than, if it is a low height embankment, the density should be more than 1.44 gram per cc, and for more than 1 meter 1.54. So the minimum density criteria should be met, and then the minimum the it should be the side cover soil, and the important is free swell index. Free swell index, you know that swelling index should be less than 50%. So all those specifications, whatever you have, and also it should be free of organic matter. You cannot have a side cover which is having organic matter like roots and other places. So it should be free of the organic matter.
Sir, shall we be 50 minutes, sir?
Okay, please. You are something you are telling, huh?
ओके सर, हम ब्रेक कर लेते हैं सर, हम 11:35 में ज्वाइन कर लेंगे सर.
ओके 11:35 पे ज्वाइन कर लेते हैं. ठीक है. आई विल कंटिन्यू. ओके, थैंक यू. So I think all the participants must have joined back. So we were discussing about the construction methodology. So the clearing and grubbing is very important. We grub it 150 like normal embankment. Whatever the stripping soil could be used as a earth cover, and also the I told you the after stripping the density of the ground should also be okay as per the 95% or 98% compaction as per specification. Then only the first layer should be there. Side cover also should be provided. Whenever you construct a fly ash embankment, earth cover and fly ash should be compacted together. You cannot do first fly ash, I will do it, make 3-4 layers and then the cover soil. No, all should be together, should be compacted so that there is a confinement and you will get the proper degree of compaction of the fly ash layer also. Addition of the side cover subsequent to the construction of the core is very prohibited, very clearly told. You cannot put a side cover after the construction of the fly ash core. No, it should be together. That is very, very important. Moisture content shall be checked at the site of placement prior to commencement. That you know that you have to check the moisture content before compaction. Moisture content, whenever you check at the field, it should normally vary from OMC to OMC plus or minus 2%. So that is as per the specification. It may vary from plus or minus 2%. You can compact fly ash with vibratory or the static roller. So whichever is available, you can do it. But finally, you should get the degree of compaction. So compaction criteria for the both national highways and rural roads is rural road, the degree of compaction, the percentage of the MDD is 98%. So degree of compaction is you should achieve is 98%. That is for the rural road. And for national highway, the degree of compaction as percentage MDD is around 95%. So you should achieve 95% for national highway. For rural road, it is 98%. For rural road, it should be a 98%. When fly ash is used in the flyovers, I told you earlier also, fly ash can be used as a retained field or a reinforced in the reinforcement portion and the retained field in the approach flyovers in the urban areas. So in such cases, how do you go about it? When fly ash is used in flyovers, either in the retained field or reinforced field, compaction methodology similar to that of fly ash embankments. You compact it, whatever 150 mm in a rural road or 200 mm, whatever you use for soil, use the conventional. However, in the case of reinforced fill, only reinforced fill means just by the side of the precast panels, the wall, care shall be taken to compact the fly ash laid within the width of the 1 meter from the facing with a plate vibrator. So you have to compact fly ash within the 1 meter, because otherwise if you run a roller near the wall will move away. So in such cases you go for plate vibrator. This will reduce the lateral stresses on the fascia and helps in maintaining the design inclination of the fascia. So otherwise your fascia will move away. In the flyovers, wall will move away if you go with the near the wall. So you should run the roller away from 1 meter from the wall, fly ash, so from the wall. Other quality control test, what you have to do for fly ash is, as fly ash would be collected from different locations within the pond and from different ponds, controlled tests for dry density moisture shall be carried out. See, there is a lot of variation in the characteristics. Suppose if you collect a pond where trucks, a huge number of trucks are coming from the pond area for when you construct a fly ash embankment, and if you take at different locations, different characteristics will be there in the pond, because in a pond, slurry of the fly ash and the slurry of the bottom ash, they are mixed and dumped into a pond. So the quantity of bottom ash is somewhere it is different, quantity of fly ash is somewhere it is different. So you have to continuously do the quality control test as I have indicated, like light compaction, highest heavy, this compaction test should be at the rate of 2 tests for every 3000 meter cube of the ash. So at every 3000 meters, at least you have to do the 2 tests. Otherwise, you will find lot of variation in MDD OMC. If you make a wrong MDD OMC, if you don't do frequent test, then go to the field and then you check with the field density. So then the degree of compaction will be, you may not able to achieve, or there will be lot of errors. So you should do the compaction test, at least 2 tests for every 3000 moisture content, 1 test for every 250 cubic meter of ash. So because when you compact it, moisture content is very important. If you do at OMC, then you can achieve the degree of compaction in a very faster rate. But in the case of fly ash, even OMC plus or minus 2%, even maybe 5% may not be much difference, because it is behave like a sand. You will get the degree of compaction. But anyway, you have to check the moisture content which is nearer to the OMC. So before accepting any layer of soil or fly ash layer in the national highways, field dry density shall be carried out either by. So how do you accept a layer of fly ash? Field density carried out either by core cutter or sand replacement. The number of tests to be conducted accept shall be as per the more specifications for road and bridge. Section 900 is the section should be followed for accepting criteria for field compaction. What is that section 900? One set of 10 measurements of density for each 3000 square meter of the compacted area. In a fly ash, for every 3000 square meter, you have to conduct 10 measurements of the field test. It is same either for fly ash or soil. It is the same. Acceptance criteria should be statistically you have to pass. You cannot say that I will just do some test. If it is more than 95%, I will pass the layer. No. For you have to conduct for 3000 square meter. So whatever you have conducted for that area, calculate the number of tests to be conducted as per the specifications. 10 measurements per 3000, and do the test, either core cutter, sand replacement. Then the acceptance criteria of the compacted fly ash layer shall be subject to condition that mean density means mean dry density, whatever you got in the field, is not less than the specified density. Specified density is 95% of the compaction. 1.65 minus 1.6 number of samples to the 0.5 times the standard deviation. So this is a statistical method of passing the layer that is given in the MORTH, that you have to follow it. You cannot compare, you cannot pass the layer just by one test or a few tests. You cannot pass. In a rural road, in the case of rural roads, average of 3 dry density tests shall not be less than the specified degree of compaction, and individual test value. It is actually in a 3 density tests in a day's work. Whatever in the day's work, you have to do the 3 density should not be less than the specified degree of the compaction. Whatever specified degree is there, 98% or compaction, you should not make. And also one more clause is there. Individual test value shall not be less than the 1% of the specified value of the degree of compaction. Individual test values, whatever you get, you should not be less than the 1% of the specified value of the degree of compaction. So this is as per the acceptance criteria for a rural road and for a national highway. I will show you some of the case histories that is very important. What CRRI conducted. This is one of the approach embankment we have constructed long back in the Nijamuddin bridge, second Nijamuddin bridge for the bridge Delhi, approach only to the bridge. Length of embankment was 1.8 kilometer. Height almost 6 to 9 meter, up to 9 meter was the height, because it is in the flood of the river bank of the Yamuna. Ash utilized is 1.5 lakh cubic meter, saving we saved around 1 crore. So this is the typical cross section what we got. So every 2 meter we have made an intermediate layer, like every 2 meter intermediate layer, and this is the cover soil. This is a subgrade, and there is a filter media, and then the stone pitching. Stone pitching is basically because it is in the river bank. So we have provided the stone pitching. So this is the section what we have constructed. So before you arrived at a construction, you have to do the stability analysis and thing. You have to check the stability of the slope, taking the characteristics of the pond ash. It is shear strength characteristics, all those things you have to take, C and phi characteristics, check the stability. Then only this slope is around 2:1. And basically the cover soil is provided because otherwise that it is a pond ash is a non-plastic material. It gets eroded if it is exposed to the river water here. Then the whole of the pond ash will go away. Then the whole embankment will come down. So we will provide a cover soil. Filter material is basically to allow it will allow the water to go out from the inside of the material and not allowing the fly ash particle. That's how you have to design the filter also. Filter also should not be coarse materials, otherwise your soil will also go away, and soil goes away, then there will be settlement also. So you should design the filter as per the filter criteria given. Then stone pitching, if flood water is there, there will not be erosion problem, it should not be there. This is some of the construction of the spreading of the pond ash. Compaction, vibrator roller has been used here. So absolutely no issue. It's a widening only, widening of the existing 2 lane to the 4 laning project. Approach to the bridge, Nizamuddin bridge. So see the compaction, it is very good without, and even if the water is more, I don't think any problem is there. You can easily compact. The same thing you cannot compact with for a soil. And there are a lot of people said that there will be settlement because this is first of its kind carried out by CRRI. So people said that there will not be settlement and there will be problem and other things. So we installed some instruments in the fly ash, some pressure cells. Then these are all the bottom one are all the settlement gauges we are installed, and its movement is monitored. How much is the settlement during the after leaving the flyover, after the opening to the traffic, we monitored it for 1 year. Absolutely there is no settlement observed. So because I told you it's a non-plastic material and it's a silt material, behavior is sand, so most of the settlement will be over within the construction period. So you don't find any construction, post-construction settlement. So that is proved by this settlement gauges. So this is the finished embankment, fly ash embankment, stone pitching, and this is how the traffic is plying on the embankment. Still now there is no problem of it. So absolutely there is no problem for the embankment. Another thing is we constructed again this is a widening project for an internal road at Shastri Park, New Delhi. So this is the design cross section. This is the existing soil embankment. What you are finding is a soil embankment, and we have designed like this: pond ash, intermediate layer, pond ash, and then with a cover soil. And we have a toe retaining wall. Why toe retaining wall is there was a water pipeline running that, so we have make a retaining wall at the toe so that the water pipeline is not disturbed. So we have provided a retaining wall, and this we have provided a backfill for the water filter material with sweep holes, so that the water can move out of the retaining wall. And the whole of the embankment was checked for the slope stability. So for 2:1 slope with retaining wall and whatever the characteristics you have to put and do the stability analysis. Stability analysis basically is what? The resisting forces should be more than the forces coming out of the live load and the dead load. So that factor of safety you have to check before you go for the construction of the embankment. So that were checked with the pond ash characteristics, soil characteristics, or whatever we have, and with the toe wall. So this is some of the stability analysis of the fly ash embankment. So you can see with a software we can do. This is the 24 kilonewton is the live load and the dead load on the embankment. This is the cover soil and this is the fly ash. These are all the fly ash characteristics, earth cover, subsoil characteristics you have to take and then get the factor of safety for the embankment. This is the construction of the fly ash. This is a filter material what we proposed in the embankment, and then your stone pitching is going, and this is the toe wall construction. So this is as per our design it was constructed with the cover soil and then the filter material and then the stone pitching. So this is how the construction was carried out at the Shastri Park. This is some of the construction. So a filter media is provided. This is a toe wall. Filter media is also provided here and with V pole, so that whatever the water accumulates in the embankment, so it should go out. So this was and it was a successful project, and until now, so the fly ash is safe. Absolutely, there is no problem of the fly ash. So both the Nizamuddin Bridge and then the Shastri Park, they are absolutely safe, no problem. Another case history I am showing here. You see the conditions here. It is in Dankuni Kolaghat in NH6 in West Bengal state. So it is Dankuni to Kolaghat. Basically, this is also a 4-laning project. Existing, you can find this is a 2-lane project, 2-lane existing. And this is the proposed 2-lane. Widening is there in this 2-lane. You see the condition of the widening here, because in that area every 6 months in an annum, annually 6 months there is a rainfall. There is a continuous accumulation of the water. Continuous accumulation of the water here. So what is happening is, because of the continuous accumulation of the water, the widening area becomes a slushy material. It becomes a slushy and very low bearing capacity material. And actually in the contractor, in the DPR, soil was earlier proposed. Soil was proposed in that area, and soil has to be good quality. Soil was available at a very large lead distance. So, and then the contractor expected that there will be a delay, and then he approached CRRI what can be done, because soil bringing is a large lead distance, cost is also increasing. So finally the Kolaghat power station was nearby. We recommended that go for fly ash instead of the soil, and he asked for us to give the construction methodology. So then what we have recommended is, first of all, in such an area, have a barrier with sand. We have make a barrier with sandbags here. Then pump out the water. That is how you have to pump out of your construction area, pump out the water. And then after pumping out, you excavate around 50 centimeter. 50 centimeter, slushy area should be disposed of. So once you pump out, fleshy area should be disposed, and then go for a reinforced fly ash basal matrix. So length is around 54 kilometer we have recommended. Height to 3 to 4 meter is the in this stretch it is there. So we recommended after removal of this is a geotextile with, this is a bottom ash. So we have given a basal. So if you want to see the cross section, you see here at the bottom, it is a geotextile wrapped bottom ash, or sand or granular material also we are recommended, because, and over that there is a pond ash and pond ash. So first of all, in this project, because contractor has the problem of soil bringing from a large lead distance, increasing the cost, so we recommended, and seeing the very weak subsoil conditions, we recommended pond ash, so that it is putting less stress on the subsoil. It is putting less stress on the soil. So I told you, specific gravity and the density of the material is very less. 2.19 is specific gravity and 1.3, 1.4 gram per cc, very light material. So when we use a right material in the height, in the embankment, it is producing a less pressure on the soil. So we recommended as a fill material ash, and the basal reinforced fly ash. Here we are recommended, instead of sand or granular material, go for bottom ash. That is also available in the nearby. So either so the reinforced geotextile at the bottom, it will not only give the stability and also acts as a drainage. It also acts as a drainage. So because it's a full flood waterlogged area, when you put the load with pond ash and other things, water tries to come above, so it can drain in this geotextile wrapped. Geotextile while wrapping is only water goes there, no particles will go from the bottom, it will not choke the drain, so then the whole embankment will be stable. So this type of application we have suggested to the contractor, and it is implemented, and it is very successful also. In urban area, I was talking where you can use in the urban areas. Nowadays, number of flyovers are built. You can use fly ash as a retained fill or a this one. In Okla flyover, in our one of the Delhi area, Okla flyover you use. This is the cross section. It is a reinforced fill. Pond ash is used as a reinforced portion. I think you must be knowing what is the reinforced area. This is the wall. This is the wall, and then these are the geogrids. And pond ash is used. See, actually, normally in a reinforced fill, you have to use a granular material. But what we thought is, first time we thought that fly ash is a silt, but its behavior is sand. So let us use pond ash and try. So we have used pond ash here for a finite meter. So this is the fascia panel with geogrids, with the geogrids, and then the for each reinforcement area, maybe around 3 meter length of that fly ash was used. Fly ash was used. This one.
भाई देख यहाँ सब जो काम कर रहा है किसी पे कोई ऐसा अपना अपना काम करता है मैं बोलूँ मेरा काम करो आप करता वो करता है
नहीं, अभी थोड़ा सा गुप्ता जी, थोड़ा डिस्टरबेंस आ रहा है.
हाँ सर, मैं चेक कर रहा हूँ सर.
हाँ, वो देख लीजिए, वो कौन बात कर रहा है, देख लीजिए.
ऑफिस में करना पड़ता है चाहे आपकी मर्जी हो या नहीं बिल्कुल ऑफिस में मर्जी नहीं चलती प्रोफेशनलिज्म में उनका पता नहीं.
So here in the हाँ.
आप खुद बताओ मैं पर्सनल काम बोलते हैं
Erection of the facing mullion, and this is the approach embankment, and here also in the rolling of pond ash is going on in this. This is some of the photo cracks support provided to this fly ash. You see here fly ash and then the geogrids. So geogrid should be tightened and then the fly ash should be laid, and at the end it should be fixed. So one layer is over, 200 mm, and again you put fly ash as per the cross section whatever I have shown you. That's how the reinforced fill fly ash is used in the reinforced fill. And another is the Sartaviyar flyover approach embankment. We used fly ash both in the retained fill as well as the reinforced fill. Reinforced, I want to just clarify what is reinforced fill and what is retained fill. Reinforced fill is basically wherever you put the reinforcement, in that portion we call it as a reinforced fill. When the reinforcement cannot be continuous now, so this is a wall, reinforcement is only for 3 meter or something. So there it is called reinforced fill. In the retained fill means in between whatever the fill is there, we call it as a retained fill. So the length of the Sartaviyar was 90 meter on one approach, and maximum it was 5 meter. So in 2000 polymeric friction ties was used. These are all friction ties or geo ties we call it as. and the reinforcements are laid in a zigzag manner. Ash utilizes 35,000 cubic meters. So used fly ash in the reinforced portion. As per the IRC, actually all reinforced earth wala, there is a one code cause IRC 102, SP 102. As per that, phi should be retained fill, phi should be more than 25 degree, PI should be less than 20. So fly ash is no problem at all. Fly ash, it has got 35, 36 degree. PA is non-plastic, so absolutely retained fill, no portion. Reinforced fill phi should be more than 30 degrees. So that is also satisfying because it has got around 35 degree, 40 degree phi. MDD should be more than 1 gram per cc. So the density should not be less. See, density, otherwise compaction will be difficult. So 1 gram per cc. So reinforced fill. So that is also fulfilling the criteria. So that is Sartavia approach embankment. And if you do the designing of the reinforced embankment, designing of the reinforced fly ash embankment, the height of the wall is, suppose you want to design a reinforced fly ash embankment and compare with the soil. I just want to show some of the comparison of the reinforced compare the reinforced fly ash and the reinforced soil. Suppose you want to design it, height of the wall as 8 meter, reinforcing material is geogrid, backfill is soil and fly ash. So we designed it with the British standard and checks were made, and this, if you get the cross section, this is how the reinforced layer, if you use soil as a reinforced fill, if you use the fly ash as a reinforced fill, you see the number of layers required for soil is 16 layers, but if you want to use fly ash, it is only 12 layers. So because of the friction angle more, you can, if by using fly ash is advantageous and also economical, only 12 layers are required. You see the bearing pressure with fly ash is only 179 kilonewton per meter square, otherwise. So suppose you want to construct a fly ash over a weak soil, bearing pressure is very less because it's a lightweight material, so it is very advantageous. So even in the reinforced flyovers, fly ash is very advantageous material for the construction. And CRRI did some laboratory characterization, and this one use of fly ash for the even railway embankment also. We given lot of cross section with IIT Mumbai. We joined, and then we did all the, because of the vibration of the rail with the train, or were tested in the IIT Mumbai for centrifugal method, centrifugal acceleration method, and we have given the designs. So pond ash with cover soil with blanket, this is for railway, ballast and other things. So some of the, and even with the reinforced pond ash also we have given with the, this is how for 4 meter height, typical sections we are given. Even we can try the use of fly ash in the case of the railway embankment also, or reinforced fly ash, steep reinforced fly ash can be used. So but this we have done in the design in the laboratory. No test sections were constructed. We are trying in the railway also. So once if the railway also start using fly ash, I think the tremendous increase in the utilization of fly ash will be there, even if it is in the railways. I was telling about lot of things about good about fly ash. I thought that I should say about some of the bad things about fly ash also. This is one of the case study I have seen. Is a fly ash embankment failure in the Noida, Greater Noida Expressway. It is just connecting the Agra Expressway. They have used all fly ash. They use in this one. So I want to just show you some of the failures with the fly ash embankment. So this is, see the fly ash failures. Formation of gullies. This is a cover soil they have put, and gullies have formed. You see the exposure of the fly ash. See, once gully, the cover soil is exposed, then water goes inside. Formation of cavity. This is fly ash. It is very clear in yellow line. You see the deep cavities coming. See, once water is exposed, fly ash gets exposed. Once the fly ash gets exposed, it will take away water, take away all the fly ash because it's a non-plastic material. It just flows. It just flows. So that's why the deep cavities have formed in the slope, and you see the complete collapse of the pavement. So these pavement failures are basically happened on the super elevated sections, on the curved portions. On the curved portion, these have happened because in the curved portion of it is a 6-lane road, it's an expressway, 6-lane road. The whole of the water of three lane either side, 3-lane, it is coming and flowing over the slope. The whole of the water is coming on the flowing of the floor. So once the water a proper condition, once the cover soil is eroded, then the fly ash gets exposed. Once the fly ash is exposed, the hole will be collapsing. So basically, superlative curved portion. In the straight portion, it's almost okay. It was no problem because there will not be any problem of the drainage. So it is basically important is proper drainage. You should not allow water to flow over the slope of a fly ash embankment. Either you should provide what you have to do. You have to go for a chutes. Provide chutes with proper. I think you may be knowing with proper chutes you have to provide in a high embankment so that divert the water slowly to the divert down through the chutes so that it doesn't flow over the slope. So that is very important. This is a drainage issue. Otherwise, you should be very careful, especially in the case of the fly ash embankment. So long term, we have proposed this compaction should be properly done. And myself, I seen the core cutter. I tried and seen the what is the compaction effort of the cover soil. It was only 85%. So they have even the soil was not compacted properly. So you should compact the soil along with the fly ash. I told you earlier, it should be compacted properly. Then only this type of erosion of the will not be there. Compaction of side slab. Toe walls, you should we have proposed you go for this curb channel with chutes. I told you chutes, curb and channel with the chutes so that to properly divert the water downstream. Provision of drains in the medians. Sometimes in a superlated, if you don't provide the median drains, then the whole of the water will go to the slope. So think of providing median drains also. Stone pitching also should be provided. Suppose only soil you provided, then there is every possibility that the water may flow over the slopes, so it may get eroded. If stone pitching is there, then the slopes will be okay. Slopes are there. So go with geotextile wrapping also you can do. So these are the long-term measures we have given for the fly ash embankment, and they have implemented in various of the fly ash. Fly in detail, I have discussed about the physical, chemical characteristics, the statutory guidelines, whatever are there, and what are the geotechnical characteristics, what are the advantages as compared to soil, and where its application, basically embankment applications, bulk utilization, and also in the reinforced in the urban areas, go for approach embankments in the urban and the railway embankment. So construction methodology is also very important. How to go with the stripping and use the strip soil as a cover soil, and compaction of the ground is very important. So and the how to go the quality control test I have discussed. You have to check the density frequently, density of the material, because there is a lot of variability in the pond ash. So every as per quality control 2 tests per 250 cubic meter, 300 cubic meter, you have to test it so that parameters can be used for finding the degree of the compaction. Moisture content should also be checked. And how to check the field quality control, you have to go for statistical methods. You have to measure 10 measurements for every 3000 square meter area of the fly ash. Then go for statistically you have to pass the thing. You cannot just fuse test and it is more than the degree of density. No, it should be statistically, it should be passed. So I have covered all the case histories, the embankment, cover soil, then the waterlogged areas. It is very useful because of the lightweight. It is putting less stress, and reinforced fill if you use, very big advantages in the cost construction because of the saving in the number of layers you get, because the shear strength is very high. So railway embankment. So I have covered all. I think hope the main thing you understood the utility of the fly ash in the road construction. Now coming to the other materials, that is also very important. I think there are people from Karnataka also. I don't know, some Tamil Nadu are there. They must be knowing about this sterlite copper. And in if Gujarat some people are there, I think they must be knowing about the Birla copper also. So there is a copper industry in the manufacture of copper from its ore during the roasting and smelting. To get the copper, the slag comes out. The copper, we call it as a copper slag. You can see the figure, how it looks like a copper. It's just like a sand material. What is the problem of using this material, copper slag? You can use it. You just by the view only, it is a sand material. 6 million tons is produced from Birla copper, Dahej, and Sterlite copper, Tuticorin in Tamil Nadu. And percentage utilization still is only 20%. Why we should not increase its utilization in the other areas? At present, it is used for only landfilling. Landfilling is just like landfilling is of no use. You have to use it for useful purposes. Cement manufacturing, that is good area. Shot blasting is also good area. Shot blasting is basically they use it for the removal of the rust and other things on the body parts of the ships. So that is shot blasting. Because it is very high specific gravity, very heavy material, shot blasting is very good technique. They use it, but they're all very small quantity. So if you want to use 6 million tons per annum utilization, go for embankment, subbase, base, bituminous layers, you should be able to do. So CRA did some studies on the use of copper slag. We constructed an embankment also in the field, so that I will go on to explain you. So there are two types of slags are available: copper slag, coarse copper slag, fine. Fine is available is only in Dahej, not in Sterlite. Sterlite is having only coarse copper slag. So basically coarse copper slag is only sand. You see here, sand content is 98 to 100%. MDD is very high, 2.1 to 2.45, very high, because it's very heavy. Copper is there, iron content is also there. It's very heavy material. OMC is less, just like this one. You see phi angle is also up to 39 degree, very high friction angle. Permeability you see -4 centimeters per second. So it's very high permeability. CBR is also very high. And in a fine copper slag, it's a mixture of sand and silt. MDD here also you can find it is more, friction angle is more, permeability is very good. So both coarse and fine copper slags are very good material for the road embankment. If you want to construct a road embankment in Gujarat or in widening portion or anywhere, you can go for it for the embankment processes and use as a replacement of fine material, fine aggregate also you can use. So basically copper slag you cannot use as it is. You see, when if you want to use an embankment, copper slag is just like a sand. See, sand, if you put sand, okay, one layer you will put it. If you want to put another layer, truck will move over it. It will go and shear it away because C is 0, phi is very good, but C is there. We want to put some cohesion should be there. So I can mix some soil or fly ash or any other material so that it gives the cohesion, shear strength will improve. So copper slag is a poorly graded sand and a non-plastic, cannot be used as it is in the construction of the road embankment. So it is you cannot use it. So needs to be mixed with the local soil or fly ash to increase the shear strength characteristics. So you can mix fly ash also, fly ash utilization, mix it, improve that. Mechanically stabilized mixtures shall meet the embankment subgrade criteria as specified in MOD more specification. So the stabilized mixtures shall meet the criteria as per the, again the mixture should fit the criteria as per the MORTH or the MOD specifications. And we did research in the office regarding the copper slag. It can be used as a replacement of fine aggregates in the subbase and base and bituminous layers also. We have found out that it can also be used as a replacement of fine aggregate. So we did the research not only in the pavement layers and the road embankment also. So what we found from our research is embankment we can go for 50 to 80% usage. Subbase we can go for 30 to 40%. So even GSB you can replace 30 to 40% with the conventional. You add for the 35% of copper slag and other material, the graded material, whatever you use. So you can go for replacement. Wet mix macadam also you can use 20 to 30%. Bituminous mixes 20. So it's a good amount that we can use in the various different layers of the material of the copper slag. And we did a test section along with Sterlite Industries and with the help of NHI. We got a stretch in Madurai Tuticorin Road, NH45B. And this is the cross section what we used. It's around 4 meter height of the embankment. It is an approach to the bridge. We have tested copper slag usage in the approach to the bridge. That is very important. Approach embankment to the bridge, very critical site because very heavy trucks also moves in this Tuticorin Madurai section, heavy loaded trucks. It's a main industrial area, and that too in a approach road we have tested this. See, this is the cross section. We have covered soil also because you know that copper slag is also a sand, and even if you mix fly ash or soil, still fly ash also it requires the erosion problem is there, so you have to go for the cover soil. So some of the construction photographs you see here. This is the copper slag and this is spread by the dozer. I predict the compaction has been done, but when you put the truck moves, entirely gets sheared away. See how it can be. Sand cannot be compacted. Sand gets sheared away because it is a cohesionless material. So then what we did experiment in the field only. We around 30 meter we selected. We brought the local soil. We mixed it with a rotavator that is available, the disc harrows. And then OMC, whatever you calculated. No, we are actually 50-50 we have mixed. So we have mixed it soil and then with water we have put it and then compacted. You see the surface you are getting in the right side. It is exactly it is fantastic. It is very highly compacted material layer we got it with a 50-50 soil. Then we made one more stretch with fly ash because fly ash was available near the industry, maybe around 20 kilometer only, fly ash. So contractor told we can use fly ash also. So because soil is, for him it is costly, fly ash is cheaper, they will supply it free of cost at the site. So we made an experimental test section with fly ash. Copper slag was mixed with fly ash. We made a layer of the fly ash first. Copper slag one layer we put and then mixed with the rotavator in the in situ only. We are mixed in the in situ, not pre-mix. You can also do pre-mixing in the WMM plant and bring it and lay it. That is also possible. But in this case we have laid with rotavators and all we compacted. You see here the surface is very good. And we asked contractor which one you want to use, copper slag soil mix or he selected fly ash because for him it is cheaper and fly ash is supplied. It is a PPP project, so naturally he will save the cost. So finally he selected the copper slag and fly ash and completed the stretch. We did some of the research there. We evaluated its modulus by a plate load test. The elastic modulus, it is 27 to 35 MPa, more than the soil. Soil is only around 20 to 30 MPa, but you got it more than the soil. And we did the DCP test. We'll get what is the field CBR in this one. CBR is also a very good field CBR. We got it. Then this is the finished road. This is the finished road with the copper slag road. Very heavy. This is the bridge is there. This is approach to the bridge. absolutely there is no settlement, nothing has happened. It is a very heavy trucks, and we did the payment performance also. We did how the for almost 2 3 years we observed the settlement, and what is the deflection of the surface, and what is the roughness. So all these things we have checked. And levels also we have taken left, middle, right, and all these things have been taken left, middle, right. All the levels have been taken continuously for about 2 to 3 years. We have taken the readings, and all the levels and other things they showed that absolutely there is no settlement. That is entirely it is safe. And roughness also we measured. There is not much increase in the roughness because we have used copper slag. And actually what we did is one approach we constructed with copper slag, another approach we did with the soil, and we compared it. Even the roughness values were good with the copper slag as compared to the soil, or almost it is same. So that's what we observed. And settlements were also it was okay. And as per the IRC SP 132, we have recommended the cross section like this. You can go for copper slag plus soil or fly ash mix here. And every 2 meter, like in fly ash, we go for intermediate layer. See, intermediate layer, I told you, it is just for construction field conditions only. Suppose if there is a rainfall, because fly ash is there, and then it will get washed away. Suppose if you are using soil, there is no need of intermediate layer. If soil is there, no need the mix copper slag plus soil and go on making layers up to the top. Absolutely there is no issue of this one. But with the cover soil is required when they use a fly ash. If you use soil, I don't think cover soil is required. So this has been specified in the code also. If you mix fly ash, better go for cover soil. If you mix soil, and then there is no need of fly ash, because there is no in a soil, if the erosion, if there is a cohesive type of or cohesion C5 soil you use, I don't think any erosion will happen. You can go for some all depends upon the type of the cover soil or type of the core material you want to use it for this one. And in the Dahej, there is a fine. This is a fine copper slag. What I am showing, fine copper slag, and we evaluated the fine copper slag as a structural fill material. Suppose what is structural fill? You want to in a confined place, you can use it as a fill, and over that a heavy platform or a loading platform can be constructed, whether it is bearing capacity is there or not. So for that we did some experiment. We made a hole and then filled the fine fiber slag. We did the plate load test and the DCP test, and this show that it has got high bearing capacity and it can be used as a structural fill material. Even a fine material, coarse material, in fact it can be used. We have tested for fine material also. You can use wherever there is a low-lying areas, fill it up with fine copper slag, then go for the any heavy platforms or any things you can go over it, or you can construct a road over it also. And based on our studies, they have used in the widening portion in the of the area copper slag. They have used it. And there is a rural road also. We have given 121 2018. That is the rural road specification, and 132 also 2022 we have given about the copper slag applications. So we got an award for that also in the this one. Another material apart from copper slag, we have a Zerofix. See, whatever I am covering here is everything is given in SP 132. So these are the materials, copper slag. We have done both laboratory field and it is fully established. So the participant should be able to use these materials without any doubts or any this one. Another material what we did the laboratory and the field is a Zerofix. Zerofix is a waste from the zinc industry, Hindustan Zinc Limited, Chittorgarh, Rajasthan. There is a Hindustan industry is there. So Xerofix is a material that is comes out during the manufacture of the zinc from the hydrometallurgical process, from hydrology metal. In the nearby the industry, and you see how it is dumped. It is just like look like a soil, but it is a Xerofix. Percent utilization is there in concrete, bricks, road embankment, and the agriculture. That is agriculture. It is only 40 to 50%. Why can't we use it in the road construction? So industry also told us that let us make a experimental test section. So there was a one state highway which is going from Udaipur to Chittorgarh near the industry. They told that us to after the laboratory report, they asked us to make a road with this material, and then we did it. So before going to that case study, what is its characteristics I should know. So it is less than 75 micron is almost it is 75%. So it's basically silt again. Silt and clay mix is there. This material is just like a silt and clay. And then PI is little bit more. Plasticity index is more. MDD is low. Density is low. OMC, FSI is quite good. 5 degree is 22. And CBR is 6. So as a material, though there are some PI is little bit more, but other properties like FSI, MDD, it is a lightweight, just like fly ash only, there is no problem. 5 degree also 22 is quite good. Soil also will get some 22 and 14. It is a C5 material, so absolutely no issue for use it in the embankment construction. CBR is also 6, so it's not it's okay material as compared to fly ash, so it can be used. This one. So we did some laboratory physical model also. See, before going to the field, we did reinforced Xerofix also. We can use in the reinforcement, just like fly ash reinforcement we did with GeoGrid in the making embankment in the laboratory. So this is the Chittorgarh Udaipur road, and this is the widening portion. Widening portion we have to use Xerofix, and this is the cross section. We designed it for the slope stability for 1:1 vertical, 2 horizontal, and then the this is the load for this. This is the characteristics. This is the subsoil characteristics. So before going to the construction, we did the slope stability. So when it is safe, then we go for the construction. So in the embankment. In the embankment portion, we have used only Xerofix, but in the subgrade portion, we have used a mix of Xerofix and soil. So we have mixed because a little bit higher strength because Xerofix has got CBR 6. They wanted 9 or 8 as per their DPR. We mix soil for the subgrade purposes. So we recommended Xerofix plus soil for the subgrade conduction. Only 100% Xerofix replacing soil in the embankment portion. So like that. So this is the finished road. What you are finding, this is the widening portion. So absolutely there was no problem. We just like in the copper slag, we did the plate load test, DCP test. We estimated the modulus and other parameters. It's quite comparable with the normal conventional soil embankment. We did the pavement performance also. We did the condition surveys, condition survey, and then the functional evaluation. Basically, functional evaluation by the dipstick roughness. How the roughness is varying if you use a Xerofix material. Structural evaluation by the Benkelman beam technique. What is the deflections? Then for estimating any settlement is there embankment, we have made pillars. which is resting on the top of the xerophyll embankment. You can then we measured the RL of this. RL of this is measured for a continuously for 2-3 years. Absolutely very minute settlement was there, very minimum settlement was there when we did the settlement with these pillars. And these are all some of the readings, the deflection readings, how the roughness values varies, other things. And all the readings showed that it is very comparable to the conventional soil. So absolutely there is no catastrophic settlement or because of the xerophyll. So it's as comparable to the normal soil that we have constructed. Always whenever we do the experimental embankment, we do the conventional soil also, and conventional soil embankment, and when we made comparison, so it is as good as a soil embankment. So what we find. One more problem with the pollution control board CPCB, central pollution, is this material has some heavy metals and may pollute the groundwater and other things. Lot of things they told. Then we told that let us do the environmental assessment, and we to collect the seepage water. What we did is across the embankment we made a pit here, and then a perforated pipe was laid, geotextile in the embankment. Sand was filled up across the whole embankment, and water collected in this pipe was diverted to some tank nearby. And the seepage water, when this was tested by NEERI, and water was tested by one of our sister concerns, who did the chemical analysis of this. Absolutely the water was safe after the rainfall. There was no heavy metal, and it proved that even the seepage water through the xerophyll embankment was safe, and there was no pollution. Even the groundwater wells were also observed. Nearby wells were observed at 8 locations, and all the water was within the permissible limits. There was no there was nothing pollution because of the xerophyll embankment. So this study showed that it is environmentally safe, and also the embankment also it can be easily used. We did the economic analysis also. Saving was there for around 4,50,000 per kilometer in comparison to soil. So this is the typical cross section given as per SP 132 2022. This is a xerophyll fill, and you can that's what I told you. For subgrade you can use xerophyll plus soil, because the low CBR you can go for mix it and then increase the CBR, because your thickness depends on the CBR. So xerophyll fill, and then you can that's how you can construct it. 100% xerophyll can be used in the embankment, and a mix of the can be used in the subgrade. This is what the conclusions we did from our studies, and based on our study, now large scale field applications were carried out. Now also xerophyll, because of our study, all of the flyovers in the case of in nearby Udaipur and all were now they are using xerophyll. See, you see here the panels, it is a reinforced panels. They are using the retained fill, and embankment also they are using xerophyll. So the NH76 they are used more than 1 lakh tons. Now still it is being used. So our study has has made contributions. Now they are using it in the flyovers as well as in the embankment. So we got an award for that also. Another material is very important is fertilizer waste, phosphogypsum for road construction. It's a from the fertilizer in the manufacture of phosphoric acid, this phosphogypsum will come out. Now 100 million tons are there. You see the huge amount of phosphogypsum is there. Paradeep Phosphate Limited, they sponsored us a project. They asked us to do some laboratory and also construct some test section, so that this accumulation there it can be removed. Otherwise it's lying there without pollution, giving pollution without any usage. So production is around 10 to 12 million tons per annum. So this is also a very important waste material. People should use it. And you see the number of fertilizer industries all over India. Fertilizer industries are there. You see the whatever location map I saw, the red dots indicates fertilizer is there all over India. So people should be able to use this phosphogypsum successfully because we have done this laboratory as well as field. So I will show you the material. Some of the characteristics are liquid limit little bit is more high, no problem. It is in the medium plastic state, but it is a non-plastic material. It's very good characteristic. When it is non-plastic, it is very good for the embankment, very good for the subgrade, subbase also. Dry density is low, just like any other waste material. The density is very low. There is no problem for that. Optimum moisture content is 17%. MDT is low. Permeability is okay. It's not very low. It's okay. And it's a good permeability only, -7 meter per second. Soaked CBR is 26. Very good material for subgrade. 26 CBR. You see the phosphogypsum. Because there is a lime added during the at the generation only, that's why it is 26. So because to reduce the heavy metals and other thing, they add some 3% lime and 2-3% lime and 3% cement. They add it to increase the pH value, to improve the pH value. So during the generation, so that helps in improvement in the characteristics of the phosphogypsum. So 26 is the CBR, and these are the Proctor curves. That what we got is here, and phi value you see 33 degree. Phi value is the 33 degree, and C is 8 kilonewton per meter square. So friction angle is very, so it can be usually used in the embankment purposes. 100 million tons accumulation should be used easily. So we did a the leather road section within the plant area only, where the heavy trucks, industry trucks will go on. First section is a conventional with the soil we did, another with the phosphogypsum. Another, we thought that it has got high density, but erosion is there, so we made one more section with cover soil also. And another is we are used in the subgrade. We are used as a subgrade material. And another we used in the as a GSB material, as a replacing the GSB. So these are all the different 5 sections. We did the laser test track in the field. Different 5 sections we did. Around 500 meters we did this one. You see the condition in the of the subsoil. Very soft there. It is in the Paradip phosphate coastal area. It is a coastal area, that's why very slushy conditions. Then we did some ground improvement by putting some using sand, excavated some material and put a sand, and over that we made the phosphogypsum embankment. You see the phosphogypsum that is laid, and this is the you see the compaction surface. It's really fantastic. So when I was there, thought that it is a more than a very good material than the soil. Phosphogypsum gets compacted very nicely. So it we did all the sections without any problem. And we did all some of the evaluation like DCP test. We bituminous layer also we laid over it. You see the finished road here. Absolutely, there was no problem of any settlement or any rutting. Heavy trucks are going on in the. This is inside plant only, so heavy trucks are going, and absolutely it is in the safe conditions. So based on that, we have this also been covered in the IRC SP 132. So it can be easily used all over the India wherever phosphogypsum is there. If you want any guidance, CRR is always there to guide you. Steel slag also can be used. That is already been shown. We have done in not in embankment but as a bituminous and subbase based material. Ferrochrome slag is also been used in subbase base in cement concrete. We can use it in the mixes. So these are all the different materials. And the last and most important is very important that I have been given is the very important is the municipal solid waste. So it is very important. I think this is a problem what we face all over India now. So R&D studies we did carried out for Gazipur, Delhi, and also we did in Varanasi, UP. Also we did some of the study whether the landfill waste can be used for the road construction or not. That was the most reason for this. And these projects were sponsored by NHAI. Gazipur generates around 3,000 tons per day, and now the accumulation is around 13 million tons. And 40 to 50 meter dump height is the Gazipur, and also Varanasi also around 70 hectares. You see how the landfill is there, the Ramana landfill in Varanasi. So whether the objective is to whether it can be used for road construction. So normally, and the present scenario of landfill management is normally we extract the leachate, biogas, and we segregation and compost biomining. We segregate the material, and with the trommels are there. After segregation, we can use it as a compost. Compost can be got it that is used for your agriculture purposes. I think you should be knowing that waste to energy plants, after segregation of the landfill, lot of RDF, refuse derived fuel, like plastics, papers, they have got a good calorific value. If you burn it in a waste to energy plants, you can produce electricity. So now in our all over India, we have waste to energy plants that are they are using the fuel from the landfill. So that is being used. So and also they are knowing in the composting, but still not much usage, because unless you use in embankment and other things, the usage will not be much. So we segregated the material and tried to use it in the road construction. And see, just to have an idea how the segregation, this actually segregation was we did it in the Okla compost plant, where they are using these trommels for segregation. Segregation means basically removal of plastics, papers, or other wood, other glass pieces and other things. So there are different sizes of the trommels will be there. It will go through 80 mm, then 35 mm. So all trommels, they segregate the material. So what we did is we segregated, we brought around 200 tons from the Gazipur, and then we segregated the material into different fractions. Actually, we wanted to know different fractions we have to segregate it. So you see here in the bottom, all plastics will get separated. Passing 80 mm, it looks like this. 80 mm, as per the MOST specification, for embankment purposes, 80 mm passing can be used, and which constitutes around 65 to 79%. 80 mm. Passing 35 mm constitutes around 55 to 65%. This is how it looks. See, when you go for finer sieve, the bigger material gets segregated, it becomes a good fraction. You see here, fraction 16 mm, it is just like a soil. 16 mm is just like a soil. 4 mm is a compost actually. This is used for the compost. So if you segregate it, naturally you are going at a uniformly material, but only thing is the organic content is a question mark that we have to see. In Ramana also there is a segregation plants are there. So this is the minus 800. So when you use 80 mm sieves, then lot of aggregates will also come into picture, and then there are some more of the plastics and other things. 16 mm, here there was 35 plus 35 and plus 16. It looks like a very good material for the embankment purposes. 16 mm in Ramana also, it's just like a soil only. 4 mm it looks like this. So we collected all, characterized it. Then we recommended passing 16 mm 44-48% and retained on this you combine. So totally around 65 to 79% can be used for the road embankment. So because the percentage of the plastics and R will be less than 1%, compaction will be easier. So this is how it looks after the segregation. These are some of the grain size analysis. So basically Varanasi and Gazipur and is basically it is a GM. Matlab, it's a gravelly silty material. Gravel. See all the why we are getting that they all satisfied the MRC specifications of more than 3 meter height. Even if it is less, there is no problem because even fly ash we are using it for road embankment. But in this case, because of some aggregates, it is a little bit up to 3 meter height. We can Gazipur and all they pass the criteria for the MRT specification. Shear strength characteristics. You see the very high friction angle, 30 degree. C is also very high. Gazipur, Ramana. So, see, once the friction angle is more very good shear strength characteristics, so naturally it can be used for the embankment purposes, very high embankment. Consolidation it becomes a less compressible material, and we did the typical results of the we designed for a particular sections we designed for 5 meter embankment also. We did all the stability analysis. And subsoil characteristics, what are the segregated material MSW characteristics, putting a load, and then see the factor was more than the 1.5. We did the settlement profile also, how the settlement take place over a period of time, and maximum settlement was less than the required settlement criteria as per the MORTH, as per the IRC 75. So it is quite good. For 3 meter embankment, this is also one of the cross section. You can have just like fly ash, you can go for municipal solid waste and have a cover soil and the subgrade and then the filter, and then you can use it. So when you use it like this, absolutely there should not be any problem. And for more than 5 meter, you can go for intermediate, just like fly ash. We can have a cover soil and then stone pitching and other things. And because of this, the usage now in the whatever our studies, we have put this in the codal provisions also, IRC SP 138, because we didn't do the test section as such as like I showed you for copper stack, phosphogypsum and other things. But one of the from the Kalindi Kunj in the nearby Delhi approach to the Delhi Mumbai Expressway. Now they are already using from the South Delhi landfills. Based on our study only, they are using it in the embankment. That photographs I don't have. So that has been used now. Though we have not done, the implementing authority now they are using it for the road construction. And these small things, the test section we did long back, that is in the subbase base, stabilized municipal solid waste was used in the subbase and base, but not in the embankment. So other waste material, we have a red mud. Other waste material, red mud is basically from the aluminum industries. Tied up with Hindalco Industries, red mud. People start selling. It is very. It's a polluted metals are there, harmful elements are there. But we have tested from Hindalco and even Vedanta. All the contents are within the permissible limits as per the permissible limits as per the specifications. So red mud also we have characterized from the Varisa and other industries, Vedanta also. Now the specifications have been developed and we are going to construct. We are going to get a sketch from NHI in Varisa. We are going to construct a red mud embankment that will also just like any other phosphogypsum and other thing. But red mud we have covered in the is a potential material in the SP 132. But whenever we get the field performance of that, we will put as a case study so that the implementing authority will be more confident of using a red mud. Foundry sand is almost we have done all laboratory. We are not done any field study. I think if we get a test section, we are ready to do it. If we can use then foundry sand. This is also a very good material. It is a sand used in the cast when the metal is molten. Metal is poured into the sand. Then how many times you can use the mold? So they will break the mold. Mold will become a sand only. So it is a basically sand only. After some burnt sand, you can say that is a foundry sand. That has also very good potential in embankment, bituminous and concrete mixes. Crushed glass, I don't have any idea that can be used in concrete. Marble slurry dust, this is also very nice. I think Rajasthan people must be there from Rajasthan. Marble dust is also has got some potential for embankment construction. We have covered this in IRC SP 132. Some experimental test section was laid. So it is also a major chapter. So you can refer that IRC SP 132 for use of the marble dust for embankment. Can use it for concrete also. Cement, kiln dust, rice husk ash, vita, they are all other waste materials. We have to do a little bit more extensive research and then we can upgrade this IRC SP 132. So what I conclude is this one is waste or industrial products. I don't like waste or industrial. We should give for either you should say, we should not say these materials as waste. It is a industrial byproducts. All are phosphogypsum, xerophix, copper slag, fly ash. They are all industrial byproducts. And Dr. Sanjay ji bol rahe the, it is not a waste. It is a resourceful material, valuable alternative material. You should be use it for easily based on our studies. Here an extensive study. You should use as an alternative material. And so you should waste should be cultivated at the source only, reduction at the source. So either the industry should able to make some adjustment in their manufacturing in the production, that less waste is generated, and after the less is generated and it should be used for the road and other concrete or other, so that we should be able to use as an alternative material for the road construction. So it should become a policy of the infrastructure development. Say the implementing authorities should take it as a policy. It cannot be, it should be a routine. It cannot be a special. What I want to say is use of waste material should be a routine matter. There should be an instruction from the implementing authorities. Use these materials, that's all. So there is no other way that they should be able to, because it is all well established techniques, well established studied material. If you are not studied, then no need to the implementing may not use it. Now that's why we have gone into the code of practice of SP 132. I think now the implementing authorities also have no problem in recommending this material in the road construction. Each state district corporation has their own solid waste management. You should have each state should know, city should know what are the different materials available there, where it can be used, and you should be wherever possible, they should be able to use it. So I conclude that waste materials protects our environment. You know that solutions they solves the disposal problem. You know how much disposal problem has industry, reduces the cost of construction. So because you are using locally available waste materials, so there results in the sustainable road construction. So sustainability is basically societal help, environmental help, reduction in the total cost of the project. So create wealth out of the waste. So that is my say. Okay, thank you very much. Thank you very much. If any questions are there, then you can ask.
Now the participants are requested, if they have any questions on the topic, please ask your questions or clear your doubts. Participants are requested, please ask your questions or clear your doubts if you have any query.
Hello.
हाँ हेलो बोलिए.
Yes, sir. Sir, myself is Snehil. Sir, my question is that the experiment you had done on
Your voice is not audible. Say loudly or
Okay, sir. 1 second. My question is that the experiment done by you on Gazipur Center, means a waste collection center, is it in use right now?
Yeah, actually, already whatever now in the just in Delhi, in the outskirts, I told you I visited the site. Though we didn't did the experimental, I think based on our study and other things, the NHI is using this material between there is a one stretch going from Kalindi Kunst to in the outskirts of Delhi to the Mumbai Delhi Expressway. There is a connection of some road is there. In that road, I visited the site. They segregated material from Gazipur and the South Delhi municipality is being laid and it has been compacted also. So it is being used already. So many tons of garbage, the landfill has been used now. Segregation is also going on. In South Delhi, around 20 trommels have been put in the South Delhi Municipal Correction, that is Okla landfill, and in the Gazipur landfill around there are 15 machines are running. So they are removing, I think, passing 30 mm. 30 mm CUs have been put. So those directly 30 mm material is been transported to the site and is being laid.
Okay, sir. Thank you.
Okay, thank you.
yes, any other participant?
One question is from my side, sir. What is basically steel slag to be used in road construction? You explained about copper slag and zinc, other things. What is steel slag basically? I just want to have a small
Steel,
brief on
it is from the steel making, in the iron making, there steel slag is also produced. It will be in the form of aggregates also. Basically, steel slags can be used as an aggregates in the subbase base and the bituminous mixes also. Not for embankment purpose, because it's a costly material. It is used for the higher layers. So that can be there. Another material that can be used for the embankment is GBFS, granulated blast furnace slag. From the blast, that is from steel industry only. GBFS is granulated blast furnace slag from in the making of iron from the iron ores. So that is the just like a sand material. So that can be used for embankment. Other from the steel making materials are all aggregates. So that can be used for bituminous and the subbase base layers. So that has been also been established. Now it can be used.
Sir, for part of fly ash, if I'm considering just like the quality of coal we get in India, like anthracite coal, I just want to ask that fly ash content is more in coal we get in India, like anthracite coal, or I have heard that in Russia or in USA we get a good quality of coal which has high calorific value, you can say. So whether it is related to content also.
Related to, I didn't hear.
Means I just want to know in which kind of coal we a high amount of fly ash. Means coal as per coal quality also it depends on fly ash content also depends on the quality of coal. My question is basically
No, both types of any type of coal. I think we there are two types of fly ashes, Class F and Class C. Class F fly ash are more in the depending on the type of the coal. We have a more tremendous coal which gives the Class F. Class F fly ash is more predominantly where the CaO content is less than 5%. In the Class C fly ash, one or few power stations with CaO content more than 5%. But ash content, it doesn't matter for me. It normally varies from 40 to 50% in our coals. Even if imported coals, it may be less also. That is none of our thing is that is calorific value. That is for the power stations to think to generate electricity. For us, only the ash matters. Ash, if even it is 42% ash content, I have to check the quality of the ash only. So there is no relation between the content of ash. Content of ash is high or low. It doesn't matter for me unless it satisfies my characteristics. So we have done a lot of studies on fly ashes from different power plants with different ash content. So they are all non-plastic. They are all high shear strength and good permeability and high consolidation geotechnical characteristics. So they are just like a sand. It is a silt material. Behavior is sand. So absolutely it is very good material for the road embankment construction.
okay, sir. Thank you.
So any other question?
Sir, I think that there is no more questions from the participant side. So
Yeah.
I will give you thank you very much, sir, for as well as the subject with
Yeah. Thank you, Gupta ji.
benefited from your lecture, sir. So
Yeah.
thank you very much. So
Thank
all
you
the
very much.
participants
Thank
are
you.
requested to join tomorrow at 9:45 a.m. in the morning. So till then, now we are finishing our this meeting.
Okay. Thank you all the participants. If you have any doubts, you can mail me. Then I will answer you. Okay. Thank you very much. Thank you, Gupta ji. Thank you very much.
Yeah, thank you, sir. Thank you.
Thank you, sir. Gupta sir. Thank you, sir. Sir Gupta ji.
हाँ जी.
सर ये पीपीटी थोड़ा सा लिंक शेयर कर लीजिए.
जैसे इस फैकल्टी सर से पीपीटी मिलेगी हम वी विल शेयर इन दिस व्हाट्सएप ग्रुप. ओके
Okay, sir. Thank you so much.
ओके
Okay.
Right.
Okay. Thank you very much. Thank you all.